Hey everybody, it's Michael. Welcome back to Let's Explore Unity Episode 3. And yeah, you heard that right. I did rename the episodes. I just couldn't take it. So Episode 0 is now the introduction. 1 and 2 are our button input test and our keyboard input test. Episode 3 is going to be looking a little bit at what the mouse can do. So we're going to get into that in just a minute. But first, a word about coding. So I had a conversation with my buddy Dao Su, who I've done some gaming collabs with over on my gaming channel. He and I have been, he's kind of a strategy gaming guy, and he and I have been talking about maybe trying to do a project together. But he's never really done any coding to speak of. We both went and got a Unity course from Udemy and went through it. And it was a pretty good course. It's pretty simple. And I didn't really notice, but he mentioned to me that, hey, these guys are slinging around jargon that I have no idea what the heck it means. And so we would go through bits of it, and I'd explain to him what they were talking about. But even that really, really basic level course was assuming, even though the guys, I think, didn't know it, a level of knowledge that maybe wasn't a reasonable assumption to make. That's pretty unfortunate, because whenever you want to do a coding tutorial, for instance, about something like Unity, where there's a whole lot of things that feed into it, you have to make some assumptions, unfortunately, about your viewers and what they know. And because Unity is about so much more than coding, it's about how all of this works and how all of it fits together. And coding is a super important part of it, but it's still only a little portion. You kind of go, okay, well, look, we got to say, well, you need to know C#. I don't think that's actually 100% true. I think that if you have any experience in coding and have some idea of how generally programming syntax works, you can look at what's going on in a tutorial, kind of figure out what the little pieces go, look at the help file, look at examples, and sort of muddle your way through figuring out how something works. But if you really want to fully grok what's going on, it doesn't hurt if you have a foundation in the language that's being discussed and understand, at the very least, the basics of it, but hopefully some of the intermediate stuff as well. So I will continue to describe as best I can some of these features and why I'm doing something the way I'm doing it and why things work the way that they work, but I will undoubtedly miss out by assuming that X viewer has Y knowledge. So let me make a suggestion that if you're going to watch these tutorials and you don't really have a fundamental grasp of coding or of C#, that you go check out some other tutorials on specifically on coding. I would recommend Quill18, who I've mentioned before. Quill18 Creates on YouTube has a basic C# series. I have not watched it. I can't speak to its quality, but I expect generally the things he does are pretty good, and we could expect that that would probably be a pretty good tutorial. From personal experience, though, on Udemy, there's a guy named Mosh Hamadani, Moshhamedani, who has a 3-part C# coding series going from very basic to advanced. I got them on a deal. I think it was like $15 each. I would have paid full price for them and thought that they were still valuable. Now, he does also have a YouTube channel. I don't know what's over there in detail, but he may have some basic stuff over there as well. But I can only highly recommend the Udemy tutorial from Mosh Hamadani. It's really quite good. He's a very good explainer. He doesn't assume that you have any knowledge that you wouldn't be expected to have when he's going through his tutorial. So that's that. Check it out. Otherwise, I'm going to just keep going the way I'm going. But if you guys have questions, please do ask. And speaking of that, one viewer did have a question. He was having trouble with Input Manager. Getting it to attach over here was getting an error about the script class not existing or something like that. Well, I think that problem may have been related to this. Let's try something here. If we create a new C# script, you're going to see that it's got a little place, it's still selected here where we can rename it. Right now it's called New Behavior Script. If we click off of this, it's going to finalize the code that's in here. And that stub code that Unity gives us a public class called New Behavior Script, which is the name of this file here. And it's derived from MonoBehavior, includes the start and update function. All right, that's fine. This guy, we can drag it onto an object in Unity. It works fine. Let's remove that. But if we now rename this, well, let's just call it test. If we rename this test and try to drag it over here, we are going to get an error. Can't add script component test because the script class cannot be found. Make sure there are no compile errors and that the file and the class name match. Why did that happen? Well, it happened because we renamed the file, but over here in code you still see it says new behavior script. Hopefully you can see that. It's very small and I don't think there's any way to magnify the interface. Our file name doesn't match with our class name inside of the file, and that is a problem for Unity. It doesn't like it at all. So we could rectify this by opening up test in MonoDevelop or Visual Studio and renaming the class to test. That would solve our problem. An easier way to solve our problem is to delete this, create a new script, making sure we don't click off of it, type test. Now when we hit enter to rename it, we're going to get our public class called test over here, and that is going to attach just fine. So just be aware, if you click off, you'll kind of mess up that thing, but you can fix it pretty easily just by deleting it and recreating a new one. And it doesn't really matter because there's nothing valuable in there, right? It's just a thing that Unity already created for us. If you ever want to change the name of a script file, you will have to, and you've already put stuff into your code, you probably will have to go in, edit the thing, and make it match up. Okay, so let's move ahead to the contents of today's tutorial, and that is, let's do something with the mouse. I want this scene to live on. Let's build on this scene so we don't have to do it every time and can save a little effort. So why don't we take O2 down here and duplicate it. And it looks like we're getting an error. So let's take a look at this error and then discuss it a little bit. The namespace global already contains a definition for input manager. Why is that happening? Well, it's happening because we have two scripts called input manager which are defining a class called input manager, and Unity can't tell them apart. So let's talk about what is a namespace. If we go over to the Microsoft Docs on C#, we'll find out that the namespace is let's read it. System is a namespace and console is a class, blah, 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 blah. Yeah, okay. It doesn't really tell us what a namespace is right here. But what it does tell us is how we could declare a namespace. The keyword namespace followed by a name with some curly brackets surrounding our class. What does that do? Well, that makes it so that sample class is a member of the sample namespace. So if we had another namespace called test, for instance, and it also had a class called sample class, these two things wouldn't conflict because they're in a different namespace. You can kind of think about it like an address, right? So there might be a main street in your town and a main street in the next town over, and if you just tell somebody Main Street, and you know, people are used to going back and forth between those two towns, they don't know which Main Street you're talking about. So you have to say Main Street over in Huntington, right? And Main Street in Hiawatha. That it's a way of declaring the specificity. We want to say that no, we're talking about sample class that belongs to sample namespace, not the one that's over there in test. We don't care about that. So we can fix this error here pretty quickly by opening up our input manager in MonoDevelop or Visual Studio and declaring a namespace. So if we say namespace, and let's call this is example 2. So why don't we call it EXO2 without holding down the shift key. Wrap this whole thing in curly braces and save it. I'm going to close it as well. When we go back and Unity figures out what we've done, it's going to take that error away. So now we don't have to worry about it. So O3 is going to be about mouse input. And so let's go ahead and set this up. Let's go ahead and wrap this in its own namespace so the next time when we copy it, we can just instantly be here. Namespace EX03. There we go. Wrap that up. Apologies if you guys can hear my phone buzzing in the distance there. So we're going to do something with the mouse in here. We can leave this little capsule movement code that we already made. Let's just call this move capsule. And let's create a little new section here under update for our mouse. Mouse input. So we know that we already saw that there are some mouse things living in the input class. We can take a look and see what we can get out of that. If I start typing the word mouse, we're going to get all the things that deal with a mouse. We got get mouse button down, get mouse button up. Those were just like the keyboard equivalents. So down is that it went down in the last frame, up is that it went up in the last frame, and get mouse button just means that the mouse button is being held down. These functions take an integer, which specifies a button. Button 0 is your left mouse button, etc. We can also get a thing called mouse position, which is going to return us a vector 3, current mouse position in pixel coordinates. And when you see that pixel coordinates, we can get a clue that, hey, we're in fact talking about the screen coordinates. We got mouse present, which is a Boolean. It tells us whether there's a mouse connected. All right, well, that's cool. And we have mouse scroll delta, which returns us a vector 2 and gives us the current mouse scroll delta. Well, what does that mean? Delta is generally a change thing. So it's probably going to tell us how much the scroll will change, but we'll have to go look at the documentation to see what exactly it is trying to give us. We don't know yet. But mouse position, we know we're going to get a vector 3 out of. Let's go ahead and do mouse position. So input.mouse position is just going to give us a value. It's going to return a vector 3. Let's see what that looks like. Let's do debug.log. And if we just put input.mouse position inside of our debug.log, we're going to get is every frame our mouse position is going to be output to the log. So let's try that and see what happens with it. I'm going to open up the console over here so we can see it, and let's press play. And if we've done this right, we should see on our console, we don't see anything in our console. Now, why is that? That's a good question. Hey, well, it turns out that occasionally debug log is apparently broken. I've never run into this myself, but sometimes it becomes broken. In the console here, we have some little buttons that we can press to decide what we're going to get displayed. This displays anything that we put to the debug log. This displays any warnings. This displays any errors. So if we click it off or on, right? So these are all clicked on. It still wasn't working. Couldn't figure out why, and kind of beat my head on it a little bit, and then just did a quick search, and it turns out that occasionally it's broken. If it's not one of these things that's turned off, and you're not getting any debug log output, for some reason, it just seems to have gotten a bit confused. So we can come over here and remove the component and then re-add the component, or at least that's what I did before, and then it should work for us. Let's see if that is the case. Oh, no, hang on. Unassigned reference exception. Oh, okay. All right. Well, that was a good example. We took this away so it lost the reference to our player object. We can drag that back in there and press play. And now we should be getting some, we're getting debug messages. Let's pause this so that we can scroll down and look at them. And we can see, we've got these collapsed. We can see that in fact it is reading out our mouse position every frame. Probably not something you want to do. Spamming the debug log isn't all that useful because you can't really read it, and then also because it actually takes some CPU cycles to do. Anyway, we're putting out the mouse position now, so we're clearly getting it. And we could do something useful with it. What useful thing would we do with it? Well, we could print it to the screen or something like that, but as we kind of noted, it's not all that useful. Putting it on a GUI element that was sitting up here might be useful if you were trying to figure something out. But in general, we'd probably want to use this in some way to interact with our world. But as I mentioned, we're getting we're simply getting, oops, I guess we want a semicolon still on there. We're getting a coordinate in screen space. So how does that help us interact with the world? It doesn't really. We have to add some other magic to this in order to make this very useful. Let's take a look at the Unity documentation over here. The input.mouse position is going to return us a vector 3 mouse position in pixel coordinates. Bottom left of the screen is 0, top right is at screen width, screen height. So fine, we get a position on the screen. How could we make that go to our world? Well, the simple answer is that the camera itself is what is interacting, is what is putting what's in the world on your screen. So camera happens to have a function called screen point to ray, which will convert that point on your screen, which is really on the can we see this here? If we go look at our camera, yeah. So see this guy here, this little cone? That's what the camera can see. If we zoom in real close to the camera, you'll notice there's like a little plane in front of it. That's actually your screen. Everything in the world is getting projected inside of this pyramid called a frustum up onto this near clipping plane, which is exactly what's going on right here. This thing is getting mapped to the screen, and that's how we're getting an image out of this 3D world with a weird thing that has a cone. So this guy here, if we pick a point on this thing right here, we can do the reverse of that. We can project it out into the world and see what's under it. So let's take a look at the documentation again. The screen point to ray gives us a ray object, which we don't know what a ray is yet, but let's see if we can find out what a ray is and how we might use it. Well, actually, we can kind of see how it's getting used down here. We're taking the ray that's been given from this screen point to ray function, and we're using a debug command called drawRay. So ray apparently has an origin and a direction, and then they're drawing it onto the screen. Let's take a look at ray. Yep, again, direction, origin. Okay, that's pretty cool. Is there a function that we can do with this? And the answer to that is yes, and it lives in the physics system. It's called a raycast. A raycast is a function that takes a ray, the origin of a ray, the direction of a ray, and then some optional things like max distance and a layer mask, which will determine what kinds of things can it hit in the environment. But all we really need is the direction, the origin and the direction. So if we take the output of this function, the mouse position, it'll give us an X and Y in screen space. Put it through the camera, it'll create a ray for us, pointing at whatever our mouse is over in the screen, in the scene. And then we can take that ray and pass this origin and direction into a physics raycast in order to do something. We'll shoot a ray into the scene. What happens if this ray goes? It returns a Boolean. So if the ray intersects with a collider, otherwise it's false. So if our objects that we want to detect have a collider on them, then this thing is going to return true. Not terribly useful because it's not telling us what is being detected, but we can take care of that too, because in physics, let's look at, I wanted to get the raycast. Well, okay, so let's go to raycast down here. We got ray. This is the thing we want. Unfortunately, I was going to show a smooth transition for how to get here, but I didn't. It's under the Unity raycasting physics stuff. But it's called a raycast hit. And if we pass this into the... Do we have our raycast? Let me get that back. Sorry, navigating this on screen is not super easy. How do we get just a raycast? It was under physics, wasn't it? Now I'm sure I don't know how this works. There we go. Physics raycast, right? I had to pause there because my knowledge of the Unity documentation is flawed, apparently. I didn't realize. I was looking for the other versions of this physics.raycast. So we have here one that takes in a vector, origin, direction, some other optional things, right? But if we scroll down, then we'll find the other versions of it. This particular one is interesting because it takes in an origin, a direction, and something called a raycast hit info. And what hit info does, if true is returned, hit info will contain more information about where the collider was hit. So what this is doing basically is we're passing it an empty data structure, and because of this out keyword here, Unity is going to fill this in with whatever information is available about the thing that we hit, what collider we hit. Is there another version that's worth looking at here? Okay, here's one where we can just pass it array instead of the origin and direction. Here's one where we can pass it array and a hit info. So this one looks like the one we want to do. Let's go and give that a go in code. So let's see. If we go to our code window, which is over here, and we take a look at this. So right now we've got it set up so that we're getting an input.mouse position. And sorry, I did not increase the code size. I should have done that. Let's do that a little bit. Okay, so we got the mouse position here. What do we need to do with that mouse position? I'm just going to comment this out for a second. Remember that our function was in our camera, and that was camera. And I'm just going to do this quickly, but if we type in camera.main, that's going to return us the main camera in the scene. We only have one camera in our scene, and it is currently the main camera. We'll discuss more about main cameras and other kinds of cameras later. But just know that right here, we're just getting a reference, an easy way to get a reference to the main camera. So camera.main, screen point to ray, if I can type, and then we want to give it a position. And that position is simply our input dot mouse position. Nope, mouse, not mouse present. And there we go. So we're getting a vector3, which is z or whatever is going to be unused. It's just going to be an x and a y position. And we're putting it into camera.main screen point to ray. If we roll over camera.main, we're going to see that is it going to tell us screen point to ray is going to return a ray. So let's create a ray. Let's just call it ray lowercase equals camera.main screen point to ray. So we're passing in the mouse position, we're putting it through the screen point to ray, and then we're getting a ray out. Okay, what's the next step? Well, the next step is the hit thing, which is done by raycasting. Physics dot raycast, and then we've got some options here, 16 of them, my goodness. We want the one that gives us a ray, that we put in a ray, and we take out the raycast hit info. So let's pass it our ray. And then we don't have a raycast hit info right now, but let's just call it ray hit. That's not what I wanted to do. I didn't want you to actually do that. Let's call it that. It's giving it red to us because we haven't defined what that is. But a raycast hit is what we're looking for, and there it is. Raycast hit, ray hit. So we're defining it here. We don't have to give it any information because this thing is going to fill it out. And then once this is done, we're going to get a result. So this is remember this is going to return a bool, right? So if we say if physics raycast passing in the ray and the raycast hit, we need an out here. I forgot about that, my mistake, I believe. And now inside of here, this little bit inside the if statement is only going to be run if this comes out to be true. All right, so we get the screen info, we pass it into screen point to ray, that gives us a ray. We create an empty data structure called a raycast hit, and we pass both of those into the physics.raycast system. That we pass this in with an out parameter so that it basically is just getting our reference to this object that it's going to fill in for us. And then inside here we could do something. So let's just output it. Debug.log, and let's see what we can get out of this. So if we take ray hit dot, and then let's see what we can get. We can get collider. We can find out what collider we ended up hitting, the distance from the origin to the impact point, light map coordinates, normals, the points, the rigid body, the texture color, the transform. Okay, that's pretty good. We could get the transform. Why don't we just do that? Now, can we debug.log that? I don't know. What can we do to a transform? Can we do toString? Yeah, we can. Let's just do toString to that and see what we get out when we run the application. Okay, so we're going to run it. Pop over to the console here. I'm going to run it. And so what has a collider on it? Well, the player has a collider on it. Oh, there you go. Told us that it found the capsule. Tells us that it found cube 3. That tells us it found cube 2, cube 1. This is finding the plane, and this is finding this cube over here. So pretty cool. So now that we know that we're over all of these things, that is pretty useful stuff, and we could probably do something with it. What could we do with it? Well, we could get this transform here. We know that, and we know how to do stuff with a transform. So what if we made, this is going to be really screwy, you wouldn't really want to do this in a game, But what if we just say we're getting the transform, so why don't we just maybe let's rotate. Let's rotate, and how can we do that? A new vector 3, Euler angles, excuse me, I believe is the term. But we can pass it in 3 floats. Okay, well, let's pass it in 0 for the x. Let's pass it in maybe 15 for the y. Actually, let's just do like 1. And for the z, let's just do 0. And let's see what happens if we do that. In theory, when we move over an object, it should start rotating. Let's see if that is the case. We're probably not going to see it with that guy. Oh, it does, actually, because our camera is attached to it. So we can see. That's interesting. I hadn't even thought of that. But notice our cube rotates. This cube rotates. Cube rotates. Cube rotates. So does our plane if I get over that. So again, not really something you'd want to do in a world probably, but basically we know that we can get a handle to an object that we're pointing at in the scene, and we can do something to that object. What else could we do to that object? Well, we can basically change anything about it. We could add stuff to it. We can take stuff away from it if we wanted to. We could interact with its transform as we did already. We could change its mesh information. So if we wanted to say that this thing is going to turn to a different color, a different shape somehow when we roll over it or when we interact with it in some way, we can do that with messing with the mesh filter. We could change its mesh renderer. And we could get its materials and do something with those if we wanted to. So for instance, we could swap out its materials or do something else with it if we know how to get these things. And that, I think, is all we're going to cover in this episode. I had actually recorded a little bit where I was talking about how to get a hold of the mesh renderer and of the material, and maybe make a change there. But you know what? Let's leave that for a future episode. This is already getting long, and I don't want to get any more confusing. Next time around, we'll maybe do something where we grab a material in code and make it change, and then I'll also show you kind of the Unity way to do things, where we actually make some interaction on the objects themselves. It's kind of the easy way to get started. It's not the best way to move forward if you plan on making like big scenes with thousands of objects. You don't want a script running on each of them, right? So anyway, we'll look at all of that next time around. I want to thank you very much for joining me for Let's Explore Unity. Please feel free to leave comments or suggestions what you'd like to see in the future, and we'll see you next time around. Thanks for joining me. Bye.